Okay, hopefully it started. Uh, Let me know if you can hear my voice. Hey, so this is a weekly tutorial live stream for Houdini titled as Algorithmic Life, and this is 154th episode. And the topic for today is to create a spherical transition effect, just like you're seeing right now. So the key idea is to transform the geometry from one geometry to another one using a sliced spherical shape just by rotating them and dissolving them from one geometry to another. So the idea itself is pretty simple. You're just slicing the geometry, one set of geometry with a sphere and rotating them with some rules and transitioning from one geometry to another. Okay. So that's the idea, and let's get started. I was wondering if you could hear the voice. Not sure if it's online though. Anyway, I'll restart if it's not recorded. So let me just show you what kind of things you could do with the setup. I have a bunch of parameters you can change, like the number of slices for geometries and the random seed, some offset value for the delay, how much each slice animated with some delays. So 0 means no delay. Will give you every slice starts animating on the same timing. The offsets values, by increasing the offset value, it will give you each of the slides starts slightly delayed with this offset value enabled. The smoothness is for the smoothness of noise function to give a direction for the rotation axis. If it's 0, you're not using any noise related value, so as a result it just rotates with one axis. And if you increase the offset a little bit more to like 0.7, you will clearly see there are some delays on the rotation. And by adding some smoothness, you're going to have a bit more randomized axis throughout the time. And if you also increase the speed, it would also create some animated noise value to change the axis over time. So that's pretty much it in terms of the parameters. And if you could also try this setup with different geometry, not just text, but like any kind of mesh geometries would still work similarly. Okay, so it's my plan. So let's get started. And I think the setup that I'm going to show you today is rather simple compared to the other tutorials that I've been doing recently. So hopefully we could finish this early tonight, right? Hopefully. So as always, let's start from scratch, and in the end of the live stream I will upload the files to a GitHub, as well as to the Patreon, so you can download the files from those pages. Okay, so first thing first, I'm going to create 2 geometries. Anything is fine, but I'll try with the text first. So I'll create 2 text. One is, let's say, Houdini is, and I'll say awesome. I mean, it doesn't have to be the same words, but this is what I have tested with, so let's go with these. Now, I am now going to make it as an extruded geometry, so I'm going to make it fully extruded. But yeah, I'll do that right here. And let's give a same distance, extruded distance to each other. So I'm gonna copy this one, copy the distance of one poly extrude and paste it here. So that will be linked. Okay, so give some thickness, whatever thickness you like. Okay, and let's also make it solid so that we could slice it as a solid geometry later. So make it output back checked on, as well as this one. Okay, now in order to determine which geometry is which, you could either create a group or set some IDs to each of the geometries. So I'm gonna put the ID attribute create. So I'm gonna create an ID for integer, for point or primitive, maybe primitive, and let's call this prim ID. Anything, any name is fine, and I'll set the value to 0 for the left hand side one, and for the right hand side one, which will be the target geometry, I'll set it to 1 as an integer. Okay, now that I have two geometries created simply by extruding, I'm going to merge them like this. Okay, now it might be better to triangulate these geometries in order to be able to have a better success with booleans. So just in case, I'm going to create a divide node to triangulate each of those meshes. Okay, so that's for the preparation, and let's actually start doing some slicing first. So the step is, the first step was to create a geometry, to set two geometries as a set. And next step is to slice this geometry using a spherical geometry. Center position could be anywhere, but I'll try with the center of this scene for ease. And after making the slice of the geometry for for the source and the target geometries, I am going to then rotate these slices in using frame, like time related value, as well as some noise related values to create some transitions from one geometry to another, also by scaling those geometries in some timing. So it's pretty easy in terms of the concept. Okay, so let's create a slice. I am going to use a for each node, for each numbers, and let's also create a null node named as controller to have all the parameters that I want to use to control the project. So one is to set the number of slices. So okay, could be 0, should be more than 2 or 3, I guess. So 3 to 100. Right, and let's set some random numbers and copy this, paste it to a iterations parameters for each end node. Now I might also need to make a normal created for vertices to have a sharp edge when after using a boolean node, just in case. Let's make sure this is one set. Okay, and so to do the boolean, since we have two sets of geometries, it's better not doing this one time. I mean, not to use a boolean node for everything at once, because that might cause some problem. Let's just check how it gonna goes. So what we need as a boolean is two sets of boolean. One is a intersection with a sphere, and another one is a subtraction with the slightly smaller sphere. So we need to have two scaled sphere geometry to trim these geometries as a slice. I mean, could be the easiest. Okay, so in order to do that, we need to have we need to determine the size of the sphere as well as the position. So to do that, before getting into this, let's move the whole geometry into a center. The center of the geometry will be better coming to the 0, 0, 0 positions. I mean, it's not necessary, but might be better. So let's use match size to place the whole geometry centered on a space. Okay. Now, next we're going to determine what's the size to cover this whole geometry with the sphere. So if we check the bounding box geometry, it looks like this. And in order to cover the whole box with the sphere, the maximum radius or the diameter of the sphere will be a point from this corner to a point from this corner. The distance from this point to this point, the diagonal points of this box, will be the maximum diameter in order to cover the whole geometry. So let's calculate that distance and use that as a scale for the sphere. So to do that, first of all, I am going to create 2 points, I guess, because we need to have one for the intersections, one for the subtraction, and each of those sizes is a bit different. The size for the Boolean subtraction will be a bit smaller. So I'm going to just want to create a point at this time, and use copy to points node to copy the sphere to the points that I created here. So I'm going to call this, I'm going to run its attribute wrangle as a detail, and let's say create points for spheres. Just need to make 2 spheres. Okay, and the size of the sphere should change based on the number of iterations of this loop. So in order to have that information, I'm going to first of all attach a metadata to the second input, and let's get that value. So iteration. Okay, let's also get the number of iterations as well. Okay, next information that I need is a bounding box information from the whole geometry. So let's connect this one to a third input and get the minimum point of the bounding box and the maximum point of the bounding box by using get bbox. Hello, Kasai. Theoretically, could you use new clip stop with custom attributes, let's say radius attributes from center or so? Yeah, you could. I guess. I am not sure how to create the side geometry for that. I mean, Boolean SOP, you could create the side faces by using the operations, but the clip will just trim the surface, the outer surface, and it's not going to create a inner like walls. So that might be a problem. Might be a way to create that walls as well, but can't really think of how in an easy manner. So you could, I mean, if you just need a like outer surface and that's the only thing you need, then that's fine. I think if you need inner walls, maybe a bit hard. I could try that later. Now let's go with the safer one first. So I have a minimum points and maximum points of the bounding box. Then let's calculate the distance, the diagonal distance between minimum and max, which will be the maximum diameter value for the sphere to cover the whole geometry. Okay, so, and let's also get the center point position of the bounding box. Oh no. Oops, that has to be 2. Okay, so we have, I think we have enough information. So let's start creating 2 points. One for the intersections, one for the subtraction. So we have a loop of 2, and let's create a scale value. Scale value, so the distance is the maximum value, right? And if you divide it by the number of iterations and multiply by iterations plus 1, since iterations starts from 1, I mean starts from 0. So I want to make sure that this value always starts from 1 to have at least a size. Now, now we have a scale value like this. Oh, maybe 1 could be 0 and 1 could be 1, so this could be just I. So we have, for this loop, I will be either 0 or 1, so this will be either, if the iteration is 0, it will be either 0 or 1. And if iteration is equal to 1, then it will be 1 or 2. And we are dividing the whole diameter by the number of iterations, so you can kind of guess what will be the diameter on that loop, on that loop iterations, based on the iterations coming from here. Okay, so I'll just put that information as a p-scale to a newly created point, not the new point, at point to a center position. I'm gonna add a, what was the name, p-scale to this point with the value that I have just calculated. Okay, and what else? Just in case, I am also going to apply some ID informations to this point coming from a I, which determines which one's which one's for the intersections and which one's for the subtractions. Or maybe it will be better with a group. Maybe. Let's set the group as well. So intersection 1 will be bigger, so I'm gonna say sub or sub. No. For intersection pt with I. So in this case, if it's equal to 0, that's for a subtraction. And if it's equal to 1, then that's for the intersection. Okay. Now, after I've created a point, I'm going to create a sphere for a Boolean operation, make it polygon, frequency to high enough value like 8, and use copy to points. Points come from second input and the geometry will come to the first input. Now if you clip it to check the section, you can see 2 layers being created, and we want to use this to kind of a Boolean operation now. And we're gonna put it into this Boolean node, so we have to split these 2 geometry. So let's go back here, let's check the group informations. So the for inter has been promoted to the copied sphere, so we can, I think we can use that. Let's use split and select for inter. Now hopefully the first input will be for the intersections sphere, and the second one will be for the subtraction, which is slightly smaller. Okay, let's say name. Okay. Now if we directly put these informations to this Boolean, for example for the Boolean 1, the first Boolean, we want to have intersections. So if I put it here, since this is the biggest one, so nothing really seems to happen, it's fine. And for the subtractions, we're going to create it here, which seems to just delete everything. Well, I guess that's because that's the largest layer. So in order to check, we have to connect it here and check a single path at some point somewhere around here. Okay, now as you can see from here, there are some issues by using a Boolean node, that this geometry which belongs to the target geometry and this geometry which belongs to the source geometry seem to unioned or merged like this, which I don't really want that to happen. It needs to be separated. So in order to just separate it, you just need to do this operation 2 times, one for the source and one for the target, I guess. I guess that's the only option I have here, so let's do that. Since we have a unique ID value called prim ID for each geometry, we could use another for each e primitive loop, specifically for each named primitive, and change the name to primid, which is an integer, so should still work. Now connect the geometry right here, which will create two loops because we have two unique IDs for the primitive. And now we could connect it here and here. Now as a result, each piece has been separately operated, just as I want it. Okay, so that's good. Now connect this back to here. Okay, so let's see, this seems to work, so let's uncheck single pass. Alright, so this is a slicing part, which is pretty easy. Now let's see if we can use a clip node. I'm not sure how to deal with the wall part yet, but let's try to guess during the implementation, see if we could do that. So similar to what we did here, we could go back to a geometries like this one, create a point wrangle. Now in order to create a clean slices, I think I need to have a bit more number of points, and at least it needs to be remeshed to have a bunch of points, so that we could have more how do I say, precise interpolations between the points as a value, in order to determine where will be the sections when we use the clip. So for those purpose, let's try using remesh. Although if we use remesh, we're gonna lose a little bit of hardness like that, so it's kind of a trade-off. I mean, you could still use half edge to determine which should be hard, but that will be too much, so I'll just try to do something like this. Okay, I think it's good enough. Let's make the smoothness a little bit bigger. Okay, well, I do still see some problem like these edges. If we reduce this, well, not sure. Oh, let's just try with these. I just want to test if this clipping method will work or not. And going inside the loop, let's just try with the one geometry. So I'm gonna re-enable the single pass like this, and let's check. Or maybe I don't really need to use a loop for this one. I don't know. Let's just try. So if it's the center, what we could do first is to set the distance from the center. That will be just the length of the P, I guess. Right, then we need to determine where to cut the pieces, which I do still need informations like the boundary information. So let's copy these. Let's just copy these two. Coming from the first input. Now, I guess it will be better. Missing one thing. Oops. This has to come first. Okay, so I'm just calling this max distance, and the length should be calculated at p minus center. Okay, so this will be the current length. Now, things that I want to do now is to create a similar value like these based on the number of iterations. So let's create the slice number. And copy this one right here. Okay, and now let's go back and copy this one here. Now we don't have any iterations, but we have a number of slices. So, and this will be max distance. Now instead of iterations, we have a distance, right? So I'm going to use this one instead. And what will be the best way? Since we need to cut it, we want to cut it using a clip. What will be the best way? So this will give you a each step distance, and I guess we could convert it into an angle for a sine function, maybe, and use it with the current distance. So if we divide it by this one, you'll get a corresponding a integer, I mean division number for this distance. If it's 3 point something, then that means it's somewhere around slice number 3, counting from the center. So what we're gonna do is now multiply this. Let's just call this val. Multiply this by pi, maybe, and not sure if this is the right way, but let's see, and use it with the sine functions, and finally and apply this into a point attribute. Alright, now, and after doing this, I am going to use a clip. Before doing the clip, I need to make sure to remember the current state using the rest node, so that we can always go back. Then create another point wrangle to use a sval to make the point positions pretty simplified, making just for the height, maybe like that, and then using clip for a upward direction, and then using the rest positions again to restore, which seems to create a odd number slices, but as you can see, without those walls sections. I mean, if you do the clipping to the negative directions, you get the other half slice, and which is, I guess, faster by increasing the number of slices. I mean, it seems like the number of slices is a bit wrong here. We need to fix that, but anyway, it's a bit hard to create these side walls using this clip node, I think. So I guess that's the downside of it. It is faster, but it's not what I am expecting to have as a result. This might be this might need to be pi multiplied by 2. Yeah. Anyway, yeah, might be hard to use this, so I'll just gonna disable it. Gonna go with the boolean, which is slower but easier. Okay, now let's say we are ready with the slices. It's time to rotate algorithmically, and that's the main part of this session. So Sally says, I saw recently tutorial where a guy used fill sop that smooths one clip part so that it becomes clean. Well, really? Shall we try that? I mean, if that works, that's great. So if we use a polyfill, maybe this one. I mean, if it's flat hole, it should create a clean surface. But if it's, I'm not sure if it's gonna still work with these rotated, like faces, hole, rotated or curved face, curved hole. Fill sop. Maybe I don't have it, or is it a custom made node? Not sure. I don't think I have it here. Not inside labs as well, I guess. Not sure. Well, if I do it here, still does not work. So it creates minimal surface. Well, yeah, I mean, you mean the fill node you were mentioning that creates minimal surface? Maybe I cannot use a minimal surface for this purpose. Like, for example, like these shape. Not sure what minimal surface, more like a soap surface, so might not work on some of the faces. Anyway, okay, so what was I? Let's rotate the geometry. So in order to rotate the geometry, first thing first, I am going to check if each one of those pieces are being cut correctly. Yeah, looks like so. And I want to have some IDs to each of those connected pieces so that I can later scale these pieces based on the center of each connected geometry for dissolving, for transitioning from one geometry to another. So I'm going to use a connectivity to give an ID to each primitive or point, maybe primitive. so that each connected pieces share the same numbers class attributes. Okay, so we have like 122 pieces. Okay, let's also get the center position of each connected pieces. Then we can use that to that as a center point position to scale each part. So I'm going to use a primitive wrangle. And for each primitive which shares the same class, I am going to set a center value. So I'm going to use a get bounding box center, but filter the group with the current class. So that you get a corresponding connected pieces center positions for each primitive, and apply that to an attribute. Let's call this concen connectivity center. Okay, let's check. So for each unique classes, you have a connected pieces center positions created. All right. Okay, now the last part, already using point wrangle to rotate using all those informations that I created. So this will be a little bit long in terms of the code. Well, let's see. Let's try. Now let's start from a scaling, shall we? Which will be easy to see as an effect. So before doing anything yet, what I would like to do is to create a frame rate value, a time-based value, which is going to be used to determine when the transition starts and when it ends. Okay. Now, first thing first, I am going to create a total frame value. Or I could say the starting frame to the end frame, either way is fine. Or I could always say that the animation always starts from the first frame. Which one's better? Well, let's just assume that the animation always starts from the first frame, and you can determine how many frames to use for the total animation, which is this value. So let's promote it, total frame. Let's say just gonna use a whole frame enable for this project, in this case 240 frame. If I change this to 120, will be changed to 120. So let's say this is just copying the end frame value here, meaning every frame will be used to animate from first frame to the end. Okay, now in order to be able to use this, use the current frame value with ease, I would like to normalize it, meaning making the range from 0 to 1, so that will be much easier to use. So I'm gonna create a value like f, which will be a divisions between the add frame divided by total frame. Will give you a volume between 0 to 1. Okay. Now, currently I don't have any delay informations yet, but before using any delays, I'll start implementing the scale dissolving for the geometry. So in this case, Houdini is word will be shown initially. So this words will be shown initially, and slowly it dissolve and change it to awesome. Okay, so to do that, we need to access the unique ID for this awesome as well as this Houdini is. So we need to check if we have that attributes available. So going back to somewhere around here, let's check a primitive ID, primitive attributes, which says prim ID. So we have 0 and 1. We need to make sure if these attributes still determines the first words and the second words. So let's just check. So if I use delete node, delete non-selected, and check frame ID equal to 0. Okay, so I see some issues here. These must be geometries generated by using a boolean, and these geometry seems to miss copying this prim ID. So I guess same for the prim ID equal to 1. Now this one seems fine, but yeah, I can see there's an issue with the boolean, so we need to make sure we are copying the primitive ID. So this is done inside the for loop node, which in this case each loop has the original geometries. So we can just use attribute transfer to a newly created geometries after boolean from original source. And in this case I just want to copy the prim ID, and let's go to conditions and just disable distance threshold. You can just override anything coming from here because your prim ID is always the same for each loop. Oops. Now let's check again. I'm gonna use the delete node again. Prim ID is equal to 0. Okay, now it's being fixed. Okay, so we have that information. What else? Yeah, so I think that's enough for a first try. So let's get that information. So in order to get that, we need to have a primitive numbers from the points. So I'm going to use the point prims. Just get the first number and we'll be able to get a primitive number associated with the point. Then from this primitive we can get the prim ID from this primitive number. Okay, now that we have an ID, and ID equal to 0 is the first geometry and ID equal to 1 is the second, the target geometry, let's try to create the simple transitions by using scaling information. So for the scaling, we also would want to have this connectivity center. So let's get that information as well. Okay. Now that we have a center positions for each part and an ID, we can start creating some scaling. So let's create a scaling value starting from 1. And for each point, either prim ID or prim not, let's create some scale. So if the prim ID is equal to 0, I would like to have a scale starting from 1. So and if it's not, if its prim ID is equal to 1, then it starts from 0. So I assume this math would work as initial value. Okay, so if this is 0, scale be equal to 1. If this is equal to 1, this scale starts from 0. Now, what we want to have next is to change this scale value from 1 to 0 or 0 to 1 based on the time value. So let's say I could say like fit 0, 1 and change the f, and 1 could be s 1.0 minus sc. Wait, the target is sc. Okay, and let's see if this is gonna work. So in order to scale it, you have to modify the @p, the point attributes, and if you want to scale it from the center of the part, you need to use this one. You need to subtract it first, so that this position will be the center of the rotation or scaling. Then multiply with the SC and made it back to the original position. Oop. Something went wrong. Now something is happening, but something is not. I am guessing maybe the prim ID, or what if I don't have a connection center? Nope. Probably due to a prim ID, I am guessing. So let's just disable all these, and this one starts from 1, and SC says okay, and re-enable the connection center. Okay, now this seems to have some problem here. Huh. Funny. So maybe let's go back to here. Check by deleting it. Okay, this seems okay. Okay, well this seems okay as well. So each part is separated, that's for sure. Okay, now let's see why this would happen. The frame. Is there a chance that prim ID might have a different value? This is obviously wrong. Okay, let me just debug this by first of all, I could still use this one instead of SC. Okay, obviously that's not good. It's not good. I might wait a minute. I might be having a problem with this connection center, maybe connectivity center. Let's see. So the class, let's just get one parts and check the connection center, which seems correct. Seems correct. Yeah. Right. And so, oh, this part was wrong. It has to be point number instead of the primitive number. Sorry for that. So that, I guess that was the reason. That. Okay, yeah, now it works. So sorry for that. I'll make this back to where it started. So it was something like this. Okay, and if so, initially you don't see a awesome wars, but then with the frame being transitioned from 0 to 1, the awesome starts to appear. So this is just a linear appearance, linear transitions, not that interesting yet. Okay, but still works. Now, addition to this, I would like to introduce a delay so that each part starts one by one based on the time. So maybe the center slice starts to scale faster, then the outer slice will start to scale in the last timing. So in order to have that kind of delay, you need to kind of change this frame based value. Currently it's just a linear value from 0 to 1 for every single point, but the idea is that for some part we want to start the frame, we want to start this value to start increasing like 16 frames or 30 frames or 40 frames like that. Okay, so to do that, I'm going to add additional parameters in order to control some offsets or delay. Okay, so yeah, it might be better to call it as a delay. So I'm gonna call this delay. And it will be better if we could just control the delay from 0 to 1. So the 1 will be the slowest and the 0 will be just scaling simultaneously at the same time. Okay, so and in order to determine what will be the, we need to take account of how many frames are we having when we are using a delay. So in order to determine how many frames we need to we have, as well as we also need to take account how many parts we have. Like if we have like 300 parts, 300 pieces, slices, which is much bigger than the frames, you cannot just delay by 1 frame, but it should be delayed by 0.2 or 0.3 frame. So knowing the number of slices is also important. So if we can go back to a new node, copy this number of slices, and go back to this here and get that value. Okay, and paste it here. So we have currently 20 slices, 120 frames. Let's say delay 0.32 or something. Okay, now having those informations, next thing what I want to do is to recalculate the delay corresponding to the number of slices. So delay is equal to the current delay which is normalized value from 0 to 1, divided by multiply by a number of frames and divided number of frames and also divided by a number of slices. So this will give you first of all, this value will give you how many frames do you need as a maximum, which can be delayed per slice. Well, actually, we don't have the frame value yet. The frame value here is total frame. So total frame divided by num slices, meaning how many frames you can use for one slice. Okay. And if you multiply by delay, then you're multiplying the maximum delay frame multiplied by some normalized value from 0 to 1, so you could always have from 0 to maximum delay value. Okay, that's the idea. Now that we have this information, we could then apply this to a frame value. So to do that, let's see. Currently I am dividing the current frame with the total frame, but instead we need to kind of modify this value and this value at the same time considering the delay value. So first of all, let's update the total frame based on the maximum number of the frames. Is it? Let's see. Let's check. So let's call this float s total frame, which is a total frame subtracting with the number of iterations. Okay, number of iterations multiplied by a delay. Is it? Yeah, that's a specific total frame for the one has its specific delay, which is slightly different. Wait a minute. Which is slightly different for each numbers, and I forgot to multiply. I think I forgot to multiply the current iterations or slice number. I think I do need a slice number somewhere. Let me see. This is just the normal delay informations, which doesn't really apply to, so that's, yeah, this is fine, and this is also fine. Now right here I can now replace it with the total frame. Now this part also needs to be modified with the delayed informations, which I have it here, by, in this case, subtracting by a number, by a slice number. Do we have that slice number? No, we don't. Either on point For primitive, we don't have that slice number, so let's bring that up somewhere right here. The slice number is just the iteration value copied from the meta node right here. So I'll just going to create a slice number, slice attributes. So I slice is equal to detail, like that. Okay, now going back to a point attribute, we have a slice attributes, which gives you each slide ID. Okay, so the maximum currently is an 18. Even though I have 20 loops, maximum is 18. Maybe the most outer slice didn't really touch with the geometry after all. So it's not a problem. Now let's go back here and let's use that information for a frame minus, what's the name, slice, and multiply by offset. No, not the offset, that delay. And the number of, this is number of slices. Okay. And hopefully we are having a new frame value which take account of this delay value. So let's just check. I'm just using the F as it is for D scale, so we can just check straight away. So what I want this to happen is that each piece is starting to scale from the center, going outward gradually. Okay, so you see a slight gradations starting from the center and at ends, outer ends. Okay, seems to work. Now if I increase the delay to a bit more larger value, start from the center. Yep, seems to work. If I set it to 1, nothing changes. Maybe 1 is not a good number. My 0.997 still works. This is more direct change. It's not that bad. Well, so it should be in between 0 to 0.999 or something in terms of the value range here. Okay, and if I set it to 0, everything just changes in the same timing, like that. Okay, seems to work. Just checking. Yep. Okay, so this seems to be okay. Now that I have the delay function enabled, let's also apply a rotation for transition. So the rotation is pretty simple because it has been cut with the spherical shape. You can just rotate in any direction, any axis, if you use the same rotational center point position. The axis could be any direction. So that's the point of this setup. Let's give some comment. Scaling. Let's give a rotation somewhere around here or somewhere around here. Okay, so let's start with single axis for simple testing. So I'm going to use a x-axis for a test rotation axis. Now, I am now going to create a rotational matrix. Starting by creating an identity matrix, rotate it using some angle. Now, the angle has to use this f value, which has been delayed. So, and f is still in between 0 to 1, so we can just use any value related to f here for the rotations. Now, let's see what kind of values that I want to set here. So, let's see. Check what I did last time. So for the rotation, I am, well, could be just f multiplied by pi multiplied by 2. So this is 360 degrees, and f is 0 to 1, so you're going to have a kind of a one full rotations from first frame to the end frame with the delay. And axis using x-axis. Okay, now I need to rotate each point. So from the center point positions, so let's also get that center point position of whole geometry, which in this case you could get it, are we having as an attribute? I don't think so, we didn't have that, but it's just the boundary, the center point position of the boundary box of this original shape, which hasn't changed, so we could just reuse that. In this case it should be 0, 0, 0, but just in case it might be different, let's which one should I use? I mean, it'll be just better having that information's created beforehand, so that we don't have to refer it each time. So let's create the center point position somewhere around here, shall we? Or here? I mean, it could be just a detail attribute, isn't it? I am getting right here. I mean, I don't really need to do that. I guess if I have it as a detail attribute right after here, maybe I can always just access to that detail attribute. So I'll just create that informations beforehand. Make a detail, center, box center. I mean, there might be a chance that you might want to change the center by parts, and those complex situations you cannot use this process. But if you are still using the same points, center points for every pieces, then it's fine. Okay, so we have center as a detail attribute, which is 0, 0, 0. Nothing to note about. Okay, let's go back. Here, we still have it. Yep. Okay, now going back to the transition wrangle. Let's access to that center value. How do I call this? Total center. Total center is detail Okay, now in order to rotate using this center point position, first I'm going to make sure that this point will be the center of the rotation by subtracting to a current point positions and rotate it by matrix, then made it back to the original point positions, which currently is 0, 0, 0, so nothing really happens by using that, but just in case you change the origin. Okay, so that should create a rotation. Let's see. And everything is just rotating at once. Doesn't really start from 0, so maybe that's something not right here. Initially this has to start from 0, but it seems not. That is because I realized that by using this calculation there is a chance that this becomes negative, but I want to clump the minimum to be 0, so I will need to make sure that the minimum value is 0 using max function. Okay, now that you don't get a negative value for the f, it's all normalized from 0 to 1, hopefully. Now if I play it, so it gradually changes from one shape to well, I was hoping that this will end with the end rotation, but it didn't, so we need to fix that as well. In terms of the scale was correct, right? So maybe something's wrong with our rotation here. Let's first check this f value. How does this f value changes if it is as it intended? So let's see. Oh, so it went more than 1 in this case. So that's also not good. It has to stop at 1. So additional value needs to be applied. Make sure that this is less than 1. And now everything is fine. So maybe it was wrong when we were doing the scaling as well. So let's make rotation 0 and let's just check the scale. Okay, so that looks correct with the delay. Okay, so if I added back the rotation, it's kind of fast. So using x-axis, now you see some issues with the colors here and there. You see some darker pieces being appeared. That's because normal direction is not being rotated together with the points. So we need to also rotate the normal. And I don't think it's a good idea to recreate the normal at this point, because if you do that, you're going to see some issues like there on the initial state. So the cleanest way to make sure that every normal is clean enough in every frames, just rotate it together with the points. And currently the normal is created on vertices, not on point, so we need to rotate those vertex normals together with the points. So let's do that. And that's not that hard. We should, since normal direction doesn't have a position, so we don't really need to subtract with total send, we just need to multiply this matte rotational matrix to a normal, the current normal, and update it as a vertex normal. Now we can either do the rotation inside the point wrangle or create a vertex wrangles and do that right there. Well, using a vertex wrangle might be easier. So to be able to use another vertex wrangle, I will pass this matrix information to a point, then reuse that in a vertex attribute, vertex wrangle. So this is the 4x4 matrix, so let's call this rot mat. So each point will have a rotation matrix 4x4 applied as an attribute like this, and we want to access to these rotational matrix for each vertex and rotate normal attributes using that. So vertex wrangle, I'm going to access a point number first from the vertex. Okay, then let's get the matrix from the point attribute. Then just re-update the normal with the rotational matrix. Okay, let's see the result. So if I rotate it, you see you no longer see any black areas happening, which was happening here. So you see the difference. This is because the normal directions has been rotated together with the points. Okay, so that looks good. Going back to a transition. Next. Next, I would like, well, one thing I noticed is that the scaling center also changes when doing the rotation. See? So in order to use this scaling, we also need to make sure that this center of the part also rotates using the same rotational matrix. So that is necessary somewhere around here. And that will create a better result. I mean the correct result. Okay. So if I play it, yeah, seems like it's correct. Now, just using one axis is not that interesting. So what I want to do next is to change the axis more randomly or more organically by using some noise-based value for the axis. Okay, so that we can control randomness with the sliders. So let's do that. So rotation, I'll say noise. Okay, and let's see. So let's create some noise value first of all. And what I want to do is to convert the noise value into a 3D vectors, which smoothly connects from one frame to another frame, or one point to another point, or one slice to another slice. Maybe the slice information could be a value for the noise, seed for the noise. So I was looking at the vex functions, which will be better to use in order to create a vector as in the direction. And I found out sample direction uniform would do the job for us. So this node will give you a three-dimensional direction, spherical directions, by inputting a vector 2 value. Sorry for that. So more like using the UV as a spherical coordinate to convert it into a 3D direction. So what we want to input is the vector 2, and my idea is to use noise functions to create a vector 2 values to apply into a sample directions uniform, which should create a smoothly connected, smoothly waved vector value, directional value from slice to slice if we use U as a noise value based on slice number. So let's try using this. And for a moment I'm going to disable the scaling so it's easier to see just the rotation. Okay, now let's go to create, first of all, vector 2 value. Let's call this noise seed using noise function, and as an input what I would like to use is the slice number, this one. Yeah, slice number. So let's copy this and paste it here. Now, as additional seed value for the noise, you could multiply this slice by, noise smoothness value, and you could also add additional seed functions to change the variety of the value output, as well as time-based value maybe. So could be a frame-based value multiplied by some function. I'll say time. Let's call this how do I call this? Time. Yeah, I'll just say time. So we have three parameters being added: noise, smoothness, seed, and time. And smoothness determines how far each slice axis are. Seed determines the variety of the output as a total. Time defines if you want to use the frame value to change the axis to have more organic results. So let's try with these values, and now we have a vector 2. Where is it? Yeah. Now the range of the noise is usually between 0 to 1, but usually the minimum will be somewhere around 0.25 to 3.3, and the maximum is about around 0.75 to 0.7. So I'm gonna make sure, I'm gonna remap this to make sure we have close value from 0 to 1 by remapping 0.25 to 0.75 to 0.0 to 1.0. It's not really necessary, but it just want to make sure so that I have enough variety of axes will be created. Now that I have end seed, it's time I use a function called, what was it? A sample direction uniform. Just by using end seed as an input, and the output will be a vector value. Let's just call it axis here. And since this will just give you a normalized directions, you can just use it as it is. So instead of using the fixed one, let's see what would happen with these values. I rotate. Now something interesting starts to happen. So currently I have so many parameters. If I set the time to 0, and if I set the smoothness to 0, axis will be just one direction. If I make this value smoothness more than 0, each axis will be differed, and higher the value is, you have more randomness for each axis depending on the slice number. And if you also increase the timing times 1, then the axis also changes by time, make it a bit more complex in terms of rotation. And finally, if I enable the scaling here, this will happen. Okay. So far we have a bunch of parameters controlling the transitions. Now next step is to control the linearity of the transitions. Currently the transition happens in linear manner. From 0 to 1 always moves in one linear speed, which happens somewhere around here or somewhere around here. So what we want to do next is to control the speed of this f value change, how the f value changes from 0 to 1 in what speed, both for the rotation, both for the rotation and the scaling. And that's the final goal for this setup. And it's pretty easy. You're just going to you can just use power functions, or you can use ramp parameters to control the speed. So for the rotations, which is using f right here, I'm going to create a new f value rf or rotf by using ch ramp or f. And currently the initial value is linear change. In order to see this clearly, I am going to make the smoothness equal to 0, time to 0, delay to some at more slower. Okay, so this will be easy to see the result. Okay, so for this one, you can just change as you like, but let's say I want to make this rotation slow, starting from slow speed, and in the middle it gets a bit more faster, and in the end ends slowly. So if you want to do that, let's change this to B-spline for smooth curve. So this indicates the x direction indicates the current f value, and the y value indicates the new value coming out, which in this case a rot f, this value. So this will be the y value, this will be the x value using this map. So by doing this, when the x is in 25%, the y value is still at 15 or 10%. But then this becomes faster in the middle, then it slows down in the end again. So if I play it, I am not sure if it's changing. That's because I'm not using it. Okay, so I have to multiply. I have to replace f by rod f. So you can see that it slowly starts rotating and then becomes faster. Let's make a bit more exaggerated, like that, like that. Yeah. So you can control a bunch of stuff right there and there. I mean, you could do something like that. Bit more octopusy movement, which I don't like, so I'm gonna make it back to where it was. Oh, why okay. So let's say this is okay for now, and I'm gonna do the same thing for scaling. So scaling also uses f right here. So let's also set a ramp parameter for scale to make sure it looks a bit more natural. One thing I don't like about the current scale is that I already see a goal target geometry in its first few frames, which I don't want. These I probably want these to appear somewhere on the middle. So to control these, the ramp also works good in this case. So let's give a scale f, creating another ramp parameter for f, replace this with f here, and create a similar curve. Now, let's see. I'm gonna make this to be spline, and what I am going to do is to make sure that the scaling doesn't change for a bit, maybe for 30%, and suddenly it changes. I don't know, let's try. And that looks better. Seems to look better. It looks a bit more natural to me. I don't know for you guys. Let's make it a bit more exaggerated. Yeah. So that looks, yeah, to me that looks better too. Initially I don't see a target geometry as a part. Okay. Now, that's pretty much it. You could also control the amount of rotations. Currently it's pi multiplied by 2, which is a full rotations, but you could add or multiply additional integers here, like how much you want to rotate in from we're using the total frame. So let's say a rot number, and if I set it to 2, you're going to have 720 degrees rotations. If you set it to 4, you have quadratic rotations, gonna be really fast. 2 is looking good. Now that's pretty much it. Now you could try out with all those different parameters, see what will change. So you have a bunch of parameters controlling a transition effect. Okay, looks good, I guess. Now let's organize this a little bit. We have coding here and there. We have parameters here and there, so let's bring all those parameters into one place, which is this one. So most of the parameters coming from this wrangle. So first of all, total frame is defined automatically by this one, so it's fine for now. Or maybe I can just bring it here. Total frame, delay. I'll call this slice delay. And the noise smoothness. So slice noise. So bigger the value is, you have more randomness. So it's actually a randomness, I guess. Slice rotation randomness, or axis rot axis randomness. Okay, a long parameter. Seed. This is also related to a slice rot axis seed. Slice rot axis seed. Okay. Time. This is another rotational axis related value. Rot slice rot axis time offset. Axis time offset. Okay. And those ramp parameters. Slice rot ramp. Okay. And also the scale. Slice scale ramp. Okay, and what else? And also the rotation number. Slice rot number, or how do I call this? Turn number? Let's start from 1 to 5. Okay, the range, the slice axis time offset could be from 0 to 1, but 1 is pretty high value. In this case, let's make this 0.1 the maximum. The axis CC could be any value, so 1 is fine. Randomness, or maybe the seed could be really high value. Randomness is you might want to avoid it could be from 0 to 10. Could be really high value to make it more random. Slice, spell mistake. Slice delay, so this is from 0 to 0.9999. Okay. Okay. What else? Do we have any other parameters somewhere? So we have already this one. So, okay. Crashed. Okay. Crashed it. So, let's see. So it's pretty much the end of the live stream. Let me know if you have any questions or feedbacks or anything. Let me just launch back the files that I have just crashed. Okay, hopefully we have crash file available. Okay, so where are we? Okay, seems like it's on the right directions. Okay, now so let's try to change some parameters and test out different result, shall we? Having more fun. So changing text is fine. Let me try changing the value to something else, like livestream for Houdini. Is ending. Okay, so play it and try to change a bunch of parameters like delay, randomness, time. This is a randomness. This is C. Okay. Parameter-wise, I think I like this slice delay and also some randomness. Combining with these two will drastically change the result. Also, if you change the number of slices, like let's say 100, if you have 100 slices, you do need to do a lot of booleans, so it might take some time for it to complete. The result looks interesting. Yep. Huh. Wait a minute. Why does it becomes more less random if I increase this value? Isn't it other way around? Oh wait, 10 wasn't a good number for noise seed, so that was the reason. I mean, if it's a multiplication of 1, noise seed seems to gives you kind of a weird result, so you should avoid using value in between, a value that can be divided by 1. Okay. Now, let's make this back to 20 something. Maybe make it less. 10. Still interesting. Okay, well, this could also work on with any types of geometry, not just font. So let's also try that, and I'll finish this. And just like I showed you on the initial setup, you could use something like pig head and rubber toy. Just replace it with the, I'm gonna use switch node to switch between first input and the second input. Now these two geometries might not be in the same positions, so let's make sure that these two are at the closed position by using match size, just moving the rubber toy to the center of the pig head and using switch. Okay, and I'm gonna copy the input so that it share with this parameter. Right, now let's see the result. And there you go. Maybe the scale timing is a bit too slow. I could always go back here, set some, yeah, looks like better result. Okay, and this might look funny with the higher number of slices. 50. More like a peeling fruit or chips, pig chips and rubber toy chips. Bean transitions. Okay. Anyway, thank you for all your comments. So I have a question. I've never done so before, but you could export an animation like this to Unreal as VAT, right? Yeah. Totally, it's possible. Since in the last animation it doesn't really change the number of points, you could make a soft body type VAT to export this to Unreal or Unity for sure. I'm not sure if the VAT components or nodes has been updated, but you could definitely do that. So not the rigid body, but if you use the soft body deformations, you should be able to bring it, since the point, just the point position has been changing it. You're not adding any points or any deleting any points. The point number doesn't change over animation, so you could use soft body deformations for this. Yep. So should work, and this is it. thank you very much for coming here. I hope you enjoy the setup. As always, I'm going to upload the files to a GitHub repository as well as to a Patreon page where people can check it for download it for free and try it out. So hopefully you have a chance to take a look at these. I'm just going to upload the one that I've just created on the live, so nothing special here. Okay, just wanted to bring the switch parameters. Okay, so that is it. Thank you very much for coming, and hopefully see you next week. I'm having a little bit of problem like what to do for the next live. I mean, I don't really have much idea, so the one that I have tried today was just made it up from in the last hour, so it's not really high context. It's just the things that I thought could be interesting. But anyway, if you have any ideas, what would you expect me to do? That would be, please tell me on the comment or anything. That would be great. Okay, so I'll finish the live here. Thank you very much for coming, and yeah. So I have a Patreon page, so if you could support me on those Patreon page, that will be awesome as well. But everything I do is open for free, so don't worry about it. Okay, good night, and thank you.